Hello guys, welcome to our next speech in Cloud and DevSecOps Z Days. And now we're gonna talk a little bit about the security in Azure Cloud with Mike Martin, the Microsoft MVP, lead consultant and architect. Mike, how is you doing today? Mike, you're on mute.
I'm sorry, forgot to unmute myself. Good morning. Good morning from Belgium, and thank you for the introduction. All right, let's get started.
One more 2 cents from my side. It's I ask audience to put the questions in the chat, and Mike will answer them, answer the speech. And also, one ask to Mike is do not forget to select the best question from the audience, and we will prepare the gift for the best author of the question. So,
All
Mike,
right,
you can start, and good luck.
Thank you for that wonderful introduction, and good morning from kind of cloudy Belgium, but then again, we love cloud, so that's what we're here for, right? Let's set off with my session here. So you're joined in a session called The Fifth Element, and for those who have seen the movie, you know this is about a threat against humanity from an utterly being that is trying to devour and to destroy everything. And one of the quotes in the movie states that in their possession are 4 elements of life, and these elements, when they are gathered around the fifth, the supreme being, the ultimate warrior created to protect life, will then, and so on and so on and so on. It's a very long quote. This single quote actually embodies the entire content of this session. So the goal of this session is to give you awareness on where security stands when we talk about an organization, but especially when we talk about DevOps. DevOps is a culture. We all know that. We all breathe and live DevOps, and there's still a lot of people that I just have to explain that DevOps is more than tooling alone. But the ultimate thing is that you embody security all over the place. And the goal is that I can show you where it is, where you can benefit from it. And I am working for Microsoft. That's just a side matter, but I preach Azure a lot, and I love Azure, and I love everything surrounding it on Azure. So I do it with the tools that I know best, which are Azure DevOps and GitHub. And I'm going to give you demonstrations with products that you can use for free, also third-party products, which are really, really cool from cool partners, where you can benefit from easy steps to implement security in your complete DevOps pipeline. Yeah, and that's actually the goal of this session. So I hope you will enjoy this session. Sit back, relax, and enjoy the ride, I would say. All right. So who am I? I'm Mike Martin. I work as a cloud solution architect, technical evangelist for Microsoft. If you want to contact me afterwards, here's my contact data. I'm not going to talk too much about myself because I have way more interesting things to talk about. But the first thing that I want to actually go over with is, what is the agenda that we're going to discuss? And what better way to discuss this than showing you the entire flow, how security will work actually in a DevOps pipeline, where DevSecOps or SecDevOps would be actually fitted in. Well, typically you start with your code base, which is insecure design. And typically we see developers not caring much or enough about security, and we should be pushing more to left. You know, this shift left organization and the shift left movement that we are seeing more and more the last couple of years. So I also want to implement at their behalf. They need to be aware that by default their code will not be secure. Because typically there's a lot of things that we can forget. In the old days, we always went from securing our parameters and hardening everything and going from there. And security was, from a developer point of view, the only thing that they need to do is provide users and access management, and that's it. But that's not enough, right? So we're going to talk about secure design, what they can do, how to help, but also secure coding, where we can actually benefit from a couple of tools that we get for free. And where everybody can benefit from, and where you can really implement easily in your development pipeline and in your development culture. And then when you go over to the secure build, which is the third element, you see the 5 elements coming together, where we then at the end talk about the secure ops, where we talk about secure deploy, which is the last part in that phase, with the monitoring and the ops after the facts, together with secure scanning and depth and dependency management on the building side. So the main layer on top is the 4 elements, and security is woven all around it, and this is where the 5th element is actually coming from. All right. So let's first talk a little bit about the security development lifecycle. And I cannot stress this enough. It's very important to, inside of any culture that you have, whether you have an agile practice, just a Kanban practice, whether you have a Scrum practice, you always end up in working together with developers, operations staff. And you need to make sure that your entire development lifecycle is secure. And this is something we've been looking at for the last 20, 25 years with a different view. And here I want to highlight that it's very important to implement some of these practices. And one of the practices that is very important is provide training to your users, whether it's your end users, but also for your developers. They need to know what kind of risks they can take, that there's such things as OWASP, that there's such things as dependency injection management and dependency risks. So you need to be training a lot your staff and your operations guys and your developers and even your stakeholders to get a good idea of what might go wrong when you design and build your solution. Next to that, a couple of other things that are very, very important is things like perform some threat modeling. Look at how your application is being built up and see how your information can flow from left to right and what kind of actions or what kind of risks that can slip in, right? Make sure that you do decent design requirement management. Very important. A lot of people don't see the whole of the solution anymore when they don't have the correct design elements. And if they have the correct design elements, they can actually derive a lot of risks from those too. Of course, you make sure that you use the correct cryptography standards, make sure that you secure all your assets. Use approved tools, very important. Don't just go for any kind of free tool that you find on GitHub or by any kind of shady website. Work with your organization to provide a canvas where everybody can benefit from the same tools, but in a managed way, and still giving freedom to your developers and your operations staff. And then most important, perform testing during and after deployment, whether it's SAS testing or DAS testing. For those who don't know that, SAS testing is static analysis security testing. DAS testing is dynamic analysis security testing. I'm going to give a couple of demos of some tools that are really handy, some tools that we have out of the box, some tools that come with an extra licensing, and so on and so on. And most important is, even after deployment, make sure that you have an incident response process, that you can validate what, if something went wrong, when there's data breach or whatever you have, that you at least can prove that you have something at hand, that you can respond in an utterly most fashionable time. We all know GDPR, you have to make sure that you respond within 72 hours. All these things, you need to make sure that there's a valid response process behind that. And of course, also provide additional monitoring after the fact. Now, let's first go over secure design. Secure design is where we start off by thinking of our solutions when we're building them. And one of the things that come to mind is the acronym STRIDE. This is something which was created in the 90s. And there's an acronym which is built up from spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Now, all these things pretty much sum up the risks that you're taking with an application and the things that can go wrong when you design your application wrongly or when you flow your application wrongly. To give you an idea, you can easily spoof an end user. Hence why we have things like multi-factor authentication. Make sure that you implement that kind of a process inside of the authentication part on your behalf of your application. But also information disclosure. Don't leave information just open. Make sure that you have a secure endpoints when you connect to your storage accounts, for instance, or all these things, right? So these acronyms will help you identify the risks and help you better to model the threats that you can find back inside of your solution. Yeah? Next to that, we have another acronym. Yeah, we love acronyms, but this is actually more the acronym that will help you grade the issues that were found in order of importance and in order of the total damage that it does. To give you an idea, DREAD stands actually for damage potential, reproducibility, exploitability, the number of affected users, and discoverability. Yeah? So this will actually grade and give the risk that you find by applying the STRIDE principles, giving it a higher or a lower score, and making it a more valuable thing to look at first, or look at it in a later stage of your solution mitigation of your risks. Right? In a nutshell, threat modeling is nothing more than what are you building, what can go wrong while you're doing this, and what are you going to do about it? So how are you going to mitigate it? So first you model, then you identify the threats, and then you mitigate. And you don't do this in a forum like you used to do, like interfaces and case design and like really designing UML. No, it's totally not that. What you need to look at how things are connected together, but how the information can flow out through your solution. I'll give you a demo in just a second. Yeah? And in the end, you need to also validate where you did a correct job for 1, 2, and 3, which is the validation step, right? So this is how threat modeling works. Now, we have, at Microsoft, we have a small tool, free. Not a lot of people seem to be aware of it. The QR code is there for your use. You can just use a QR code, or you can use the vanity link, aka.ms.tmt preview, where you can download this thing, and this will give you the correct page where you can find it. So how does this work? Well, I have a solution here open. So this is actually an official PaaS web application where we did some threat modeling on top of, not too fast, where we did some threat modeling on top of a public web app, which is being authenticated and unauthorized through Azure Active Directory. And you can see all these lines, and you can see all the different flows that are going here. So we have a browser and a client that actually is accessing this web app. And you see that if I select the operator, you will actually see here that there's a lot of properties that you can set, and you can say what kind of an isolation level there is and how these things are acting when you interact with them, whether it's all the scope, yes or no, what kind of a connectivity you have between the two systems. So in this case, it's HTTPS that we have. So you can say whether it's a data flow or physical network, whether it transmits something, whether it's a SOAP payload, a REST payload, and all these things. Now, if you set all these parameters correctly while doing the modeling, this will give you a mitigation list, a risk list where which you can use as a checklist. So this is like a visual style drawing that you do. But the most interesting part here is that if you go to the analysis view, this will give you a full list of all the risks, all the possible risks that your application can rely to. Yeah? So here you can see, this is where our STRIDE acronyms come in. Here you can see, for instance, if I highlight this one, you will see that there is a possible data flow interruption as a denial of service kind of category between the Azure portal and DevOps. Yeah? We can also do, like, for instance, spoofing of a destination SQL store, and then we can spoof the SQL data by an attack. Yeah? And as you can see here, you can then go for the change the status on it, whether you are working on these things, yes or no, whether it needs investigation or whether there's this false positive for you, but it could be that that's not applicable to you. Or whether it's already mitigated. Now, this is very nice when you see it on screen, but it gets even more nice when we generate a full report. And then this will generate a full HTML file with all the different steps that you need to take to safeguard everything. So I can just do, I'm going to put it on my desktop where all the important things are. So I'm just going to put this at 0 days. So generate a report for me. And in a couple of seconds, my report is being opened. As you can see, the entire thing is being highlighted, and all the different pieces will be highlighted where the information flow is being executed, what the steps are that you can do, and you can use this. You can integrate this in your wiki. You can integrate this in your DevOps tooling if you have it, just as a checklist where you're doing and validate whether you're doing a good job or not, whether you mitigated those risks. So at least even if you didn't start doing threat modeling yet, use it and do it for new stuff. So at least you have an idea what's going on into your application. Reverse engineering threat modeling is also a possibility, and then you can even create some technical depth on that. So that's pretty cool. So another on threat modeling and on design part, let's talk a little bit about secure coding. And even there, I talk a lot to .NET developers, but even on other application developers like Java developers or Node developers or whatever technology you're fond of, we have the similar kind of tools that are existing. But I have one in particular which we have as a free tool and as a free plugin inside of Visual Studio. And it even works with VS Code if you're using Visual Studio Code, and I will demonstrate that. What this does is it is a Roslyn analyzer on top of .NET. Hence why I said the shift left part is very important, because this starts actually in the IDE of the developer. So the developer is really important in this part. There's some other tools also like shift left scan and all these things, but this one is particularly interesting because it does a Roslyn analysis on top of your Visual Studio Code. So if I open up my Visual Studio, as you can see here, there's squiggly lines under here, and I can hover over it, and as you will see here, there's a Roslyn error actually saying security analysis CS. The HTTPS or HTTP option is insecure as it allows the use of HTTP. We all know that we should be endorsing and enforcing HTTPS wherever we can. So it's better not to use HTTP, but only use HTTPS. So this Roslyn analyzer will actually analyze the entire source code that you're working in. It works pretty fast, and you can just switch in between. It will generate upon the reading of the environment. There's a better one here in the Active Directory sample. It should be opening pretty soon normally. There you are. So as you can see, a lot of things come here, like custom token cache identified. Don't do that. Use SDK. So we give you best practices for implementing code security where we can. We also have this in VS Code, and VS Code is your open source IDE, which can be used on any platform. And the beauty of it is that we also have these things here, as you can see here. So here we have blob container access. This is the same kind of security scanner, the Roslyn analyzer, that is being accessed here. And as you can see here, this will give you a best practice for interacting with blobs, for instance. But also for a crypto sample, there are some issues in here. As you can see, it will highlight a tree. And so these are the issues that we have. And here it will say, well, fix guidance, use SHA-256 instead of DMD5 decryptor, because we all know this is kind of deprecated in the security world. So we should be using a better encryption and algorithm here to work with that. When we're talking about secure code, we sometimes also have the tendency to put in keys and credentials inside of code, which is a very bad practice, by the way. You shouldn't be doing it, especially not when these code parts are publicly available when we serve to a website, for instance, like web.config files and stuff. Don't do that. Use instead things like key management systems. And in Azure, we have Key Vault, and Key Vault can work seamlessly with your DevOps CI/CD pipelines if you want to, because you can easily just get a secret, authenticate a user against the key vault, and push the secret back inside of your configuration while you're building it, for instance. And that is a way better mechanism to handle your secrets. But also, when you're doing it in production, you don't have to worry about the secrets and deploying your secrets upon the creation and upon the deployment of your solution. No, Key Vault will actually get the keys once a user is authenticated or once the solution is authenticated, and it will get the keys in an authenticated way. So that way, nobody knows the keys. The keys don't go out in the open. The connection between two systems are fully encrypted, so there's no man-in-the-middle attack possible, and your keys will be safe. Now, there is a helper in the .NET core sphere where we have a Key Vault configuration package, which actually helps you build up this kind of thing inside of .NET Core. So if you're building for .NET Core, this is a better way to implement Key Vault from your code perspective if you've never worked with Key Vault before, because this will set it up for you. This is a little bit of information. You will get the slides afterwards. I will make sure that they get published somewhere. This is a little bit of additional information what Key Vault actually can do for you. Now, in the case that you actually have like spilled keys inside of your source code, and you never know if it happens, and you're using like public repos in GitHub, for instance, we have you covered. In GitHub, there's something called CredScan, and CredScan can actually scan your repos, and don't worry, we don't abuse those codes. You're the only one that can actually see these things. But we block the code and we give you a part of information saying, hey, there's a key or a credential or a secret inside of your repo. Make sure that you take it away, because this is a very unsafe practice. And we can get actually access to your systems in the backend, and from there we can actually do more harm. And before you know it, somebody is doing some lateral movement inside of your organization, and you don't want to be the next, like what are they called again? The hotel chain, you know, where all your information got spilled, and where a hacker spends like 6 months in your organization. That's something you totally want to avoid. So let me demonstrate this really quickly. We have in GitHub, and let me go to my GitHub organization. So github.com. We can scan for credentials, and this is something that you need to set up yourself because you need to enable it. So if we go to the security part of our environment, as you can see here, there's this little thing called Detective Secrets. Let me just make my screen a little bit bigger for your visibility. So if I click this, you will actually see that I did an oopsie, and I put a connection string inside of my code, which is a very bad thing to do. And it's even worse because I was so stupid that I even put in a password in there. As you can see, this will hurt bad. Of course, if anybody grabs my password, this can be really, really risky and dangerous for your organization. So this thing will actually be set up from the security part inside of your GitHub repo. This works for organizations. This also works out of the box without you having to enable it by default on public repos, just to make sure that none of your code gets spilled publicly. Yeah? So this is really important to know. Okay. If you're still using Visual Studio 2017, you can do the CredScan part on Visual Studio itself, and there's a plugin for that called the Continuous Delivery Tools for Visual Studio, which actually does CredScan inside of the IDE. You get the same kind of Roslyn Analyzer or Regex Finder, which can look for passwords and all these leak credential types. But unfortunately, it only works with 2017. So just so you know. Great. Now, doing secure coding is one thing on the IDE side, but you also need to make sure that you provide enough security on your CI/CD and repository, and actually your full DevOps tooling chain. Yeah? And one thing that you need to make sure of is that you provide there also the principle of least privilege. So you're not going to give everybody the same access. Make sure that they have the correct accesses inside of your DevOps pipelines. And or in GitHub for that matter. Make sure that they only have read access when they need read access, that they can have this destruction access when they are allowed to be destructing things and destroying things. So make sure that you give them the correct privileges for those who need it. As stakeholders, for instance, in Azure DevOps, they only need read access, right? So you don't have to go the entire mile. Of course, if you want them to let them kick off a build or something like that, then you need to make sure that they also can be working with those kind of services. Now, there's one thing that I do want to show you is in Azure DevOps, if you're using Azure DevOps for your build pipelines, we also have a cool system which can scan for your security on your environment. And for this, we have a which I call, I need to open this thing, a scanner that will actually scan the environment. No, it's not this one. I need to open the correct one. It's this one normally. Should be. Which actually scans for the how well your security is being. No, wrong one. Darn it. Forgot to open this one. This will actually scan for the correct deployment and the correct configuration of your. I couldn't find it. So the correct configuration of your DevOps environment. So if you take a look here, quickly just check this one. Should be one here. Is it this one? No, it's not this one. Got to open it up. I have too many projects. This should be the one. Yeah, this is the one. Yeah. So what this does is this will scan your environment, and upon every build, you can actually say, how am I performing on securing my own environment in Azure DevOps? So here you can say, don't use any classic resources on a subscription, all these things. This will actually totally scan your environment, whether your agent pools are secure, whether they should be only limited to that release pipeline or not, for those who know Azure DevOps. And this will actually give you a more granular control on how your DevOps organization is working with Azure DevOps and who has access and where not. So this is a very cool reporting. This comes as a build step that you can implement. It's part of a bigger whole called the Azure Security Toolkit, which can be downloaded. And I'm going to talk to you about that in just a second, what else is in there. So let's bring it up to the secure builds. So secure builds, we have today two kind of build pipelines, which are very popular, which is first Azure DevOps, because it's still free to do builds on there for any kind of project. And you can easily just implement all these build steps for free. And there's a lot of security features in there, demonstrating a couple of them in a second. Which can help you identify risk, but also dependency issues and all these things. And even GitHub in Actions has a lot of these things available. And we even provide some additional tools there, like code scanning and Dependabot, for instance, to scan security issues. So let's first go over to AZ Escape. So Azure Secure DevOps Toolkit is something that we developed internally to do secure development and secure DevOps inside of Microsoft. Yeah. We brought it out to the world, and it has some additional tools in there. It will scan specifically for Azure when you're doing deployments, but also builds or deployments. So what you have here is a toolkit that can be implemented inside of your DevOps pipelines, whether it's Azure DevOps or whether it's GitHub Actions or even Jenkins, because you can do this by means of a scripting tooling like with PowerShell. And this will scan either your ARM templates if you're deploying Azure through ARM templates, or it can scan after the fact if you want to cross-validate with your deployments that you're going to do and make sure that your the security on your subscription is still okay. Right. Let me demonstrate that quickly to you. I already just ran a scan before I started it, before I start my session, I mean. What it does is, it's just, as you can see here, is just a PowerShell command line that you do. It comes with the AZSK module. You can install it very easily by install module AZSK, and it will download it and it will install it for you. And they have some module, then you have some commands in those modules, and they all start with AZSK and then what you want to scan. Now, for instance, here I did get AZSK subscription security status, and I scanned my subscription in Azure to see whether I'm doing a good job on securing it. As you can see here, I'm doing pretty okay. There's only a couple of failed resources that are not doing a good job. So, and that's on purpose, by the way, because elsewhere I have no demos to show you. And what it does in the end, this will give you a CSV file, which you can open then with Excel. And then you can, from there out, you can start looking at the things that are in there. So if I do this, for instance, if I just open up and I say home, and I do a, not a wrap text, I need to data, sorry. I need to do a text to columns. I need to make sure that I do a delimited. There we go. I make it by the comma. Voila, finish. I can make it even a little bit more pretty and more readable just by doing this. I can just do home, make it into a small table. Here we go. Yeah. I have my table as headers. And now I can actually filter on all the data that I have here. So I just want to, the things that are interesting to me are the things that failed, because these are the most risks. Or you can also do the verification only. But here I can have, for instance, these are the things that are risky. For instance, this one. Here I have the issue, do not grant permissions to external accounts. So apparently, and I added myself inside of my subscription. I added myself as an owner inside of my Azure subscription. That's a security risk because you don't know what this person will actually do. Actually, you can know what they're doing because it will all be audited. But still, if you make them an owner, you make them actually king of the world. Yeah. So all these things can be then validated. There's a lot more in there that gives you Power BI access with the reporting on top of that. And they can be, these steps can be integrated inside of your pipelines too. You can even do a scan on before your, so I can just do this one, and I can set, say, what is it again? Get AZSK ARM template security status, and I just need to give the ARM template on the template that I want to look at, and this will then scan my template for all security issues there too. So you don't only have to do it on the part of the subscription. You can do it on ARM templates before deployment, post deployment, all these things. So there's a lot of tools in there that can actually help you. We have another tool called the ARM-TTK. ARM-TTK is an additional checker on ARM templating. I'm not going to demonstrate this because I'm limited in time, but this will also give you some validation on whether the formatting is correct and whether you should remove some stuff in there. It works in a similar way as AZSK, and those two combined are actually pretty cool. Now, this is on your resources. Yeah. So this is on the resources. Let's take a look now on our coding skills specifically, and specifically on when we're using dependencies. Now, one of my favorite tools before GitHub implemented something ourselves was WhiteSource. And WhiteSource Bolt is a free tool that you can use. It also comes in a paying version, which is WhiteSource, and it integrates nicely with both GitHub and Azure DevOps. And the cool thing about this thing is that it actually has, and let me just quickly open up my browser again. It has some nice reporting capabilities. I can close this one. It has some nice reporting capabilities, as you can see here. So let me just go back to my original run. And I also have one here. So let's see. So this is the Bolt implementation. This comes for free. So this is a report that I did on a build earlier. So it's pretty secure. My code is very secure when it comes down to dependencies. There's no outdated dependencies on, and this is a .NET project, for instance, but I'm going to show you one in a second on Node. So I'm doing pretty okay there. And if you then take a look at the WhiteSource itself, you have a little bit more granular control on this one. When we talk about your reporting, you can do this either from the build itself, or you can have a separate integration on the building itself. And here you have a good idea. This gives me a high risk, but this is because it scans on a different level, and there's some other stuff included here too, as you can see. So there's some vulnerability libraries that you can check out. There's how what the severity distribution is. So the vulnerabilities that are highlighted, as you can see, it uses CVE vulnerability. So this comes from a universal database that everybody can use where vulnerabilities are being reported. And they use that tool too to highlight the vulnerabilities that have been set there. So, and from there out, you can actually take a look what you need to do, or just update your dependencies on top of that. Right. There's another one that I run earlier. This one, for instance. This gives me a very nice failed WhiteSource bolt report. No, it's not that one. Sorry, I need to go to a other build, a previous build. That's this one. Yeah, this will give me a better look. As you can see here, this will give me a more risky one. It's very red, so that's not good. So you should not be doing these things, right? And they even have an outside of Azure reporting tool if you're using the full paying version, right? We come to SNCC, and SNCC is also very cool, and they added some really cool stuff like infrastructure as code scanning, just a little bit like with the ARM templating, but you do that also for Terraform and all these other cool things that we have. And you can even do Helm. If you're doing Kubernetes, you can even do Helm scanning if you want to. A lot of cool things. They do container scanning on that level. And it also comes with a lot of free stuff as a free SKU. So you can really easily onboard on that. What I'm quickly going to show you here is the SNCC report that it will generate from out of Azure DevOps. As you can see here, there's a little bit the same thing, but it also scans inside of the code. And it will show you what kind of a cost impact it will have, and what kind of a cost in a technical dev kind of way it will have, and all these things. It's really, really cool. And they have a very nice set of dashboards where you can take a look at all your environments, and you can even implement a PR on those things, and you can look at all the different vulnerabilities from there out, and it gives you nice reporting on top of that. All the as you can see, all the issues and the remediations and all these things are very nicely highlighted. So you don't have an excuse anymore to implement these kind of things, because they're fairly easy. You just need to add one line inside of your pipelines, whether it's GitHub or SNCC. And it works very nicely out of the box. And even for SNCC, you don't have to do it inside of your build. You can do it immediately on your repos if you're running any kind of integration. Even for WhiteSource, there's an immediately integration in most of the commonly known repository parts. One of my all-time favorites is also still SonarQube. And SonarQube has so much on board. I discovered SonarQube about 10 years ago when I was doing projects on technical depth with, and specifically more on the scale coding, which is the little A that you see on the screen. So scale gives you a valid or an invalid score, like a report card, whether you're doing good in a code quality perspective. Now, they also have some security scanning features on board. The community edition comes for free. I run my environment in a Azure app, so you can in a Docker container, so you can just easily set it up, build it, and tear it down again, and you can use it inside of your build steps. I can show you that where that is. So if you take a look at the build pipeline, I think this one, yeah, I can just open it here. If you look at the build pipeline here, you will actually see that there's a build step for this one. Just edit it quickly. There's a couple of build steps that you need to implement, and it works the same for GitHub, for GitHub Actions. There you go. You first need to prepare, and then you go and run the code, and then you will go and publish the code, right? So if you take a look at the results, this will give you some security hotspots. where you need to pay attention, and this will give you also now hard-coded credential scanning, so that comes out of the box for free inside of that thing, with all the different risks that are at hand, but also CVE scanning, which is more in a paying version. And the beauty of it all is, if you take a look at the issues, you have a full overview of your code. It even does that in code scans as bugs, but also the severity will be highlighted. And when you have the paying version, you can also see whether it's an OWASP.10 issue or whether it's a SAN issue or CWE a CWE risk, right? I did one for a Node application, but I also did here one for a .NET application. As you can see, it gives me different results back, and there's a lot of major things in here that you shouldn't be doing. So all these things can give you a good understanding, and it gives additional information on your code quality too. You can implement, if you're a ReSharper user, even those quality controls can be put in there. You can do Java at the same time, so all languages are supported. Pretty cool stuff, and it's still open source, right? I'm almost at the end. I discussed already 3 out of 4 pillars are surrounding the 5th element. Let's talk a little about secure deployment, right? So secure deployment, I showed you already the SAST scanning, so statistical analysis, which is Snake and SonarQube and all these things, and also oh yeah, I forgot to actually show you one, which is also very nice, of course. I showed you secret scanning in GitHub, but we have also out of the box. And my browser's not reacting anymore. All right, this is awkward. All right, let me just open up a new browser, github.com. There we go. Let me just, browser is not responding anymore. Oh, browser is not responding anymore. I hope my screen is still visible. Yes, it should be. Come on, yeah, here we go. So github.com, voila, and I go to the same organization again. So what I did here is, here we go. Yeah, sorry about that. Murphy, you know. So let me go to my org. Let me just quickly sign in here. Sign in to validate, authenticate. To race against the clock, you know. There we go. And that's a 6-digit code, so that's 783. MFA, you should always go for MFA. Phone is your friend, or whatever kind of MFA you have. There we go. So I did the demos Z-Days thing that I set up earlier. And what I did here in the actions, I also have security code scanning. So I do code scanning by means of GitHub. You can implement any kind of code scanning tools yourself. I set up the standard one that we have, which is CodeQL, which is a SQL-like-esque thing that we have, and that can be easily implemented inside of an action. And how does this work? Well, you just go to code scanning alerts inside of the security tab on your GitHub repo. You set up this workflow, and then it will create a YAML file, and that YAML file will be implemented inside of your code. And then it will start off every single time you do a check-in or whatever kind of action that you want, trigger that you want to be defined. You do the code scanning QL. What it does, it will go scanning your code, as you can see here. It will analyze per language, as you can see, because since it's a .NET core, you have some JavaScript and some C# and it has different code analyzers, and then it will do some CodeQL analysis, and I can quickly show you this how this works. So what it does, it scans, so it analyzes the C#, and what it does, it will go over every single kind of file that it finds and looks, and it validates against the database with all the different code qualifications that we have that are at risk. So that's really cool, and it's really useful. It comes with a paying version of GitHub, but it is really good. And you can even do this outside of actions too, and you can create your own queries. Really powerful. Now, This is for a statical point of view. From a dynamic point of view, there's a lot of tools available. One of my most favorite one, which can run from a headless point of view, but also from a integrated point of view, is the OWASP Zap scanner, Zap proxy. You can run it yourself very easily in a container. And what this will do, this will do actually a full graded attack against your resources. And then it will give the results back from a production perspective. And this can be really easy integrated inside of Azure DevOps or in GitHub by using a couple of CLI lines. And from there out, you can work onto those. Now, again, when you're deploying, you also need to make sure that you do RBAC at its best when you're doing Azure. Apply the principle of least privilege. So make sure that you don't kill that off, and make sure that you do inheritance on the privileges too. Now, leave this for your reading, but make sure that you have a good governance plan for that and apply policies, because this will also help you secure all the different issues, right? So next to that, I'll leave this for your reading. This is a little bit about on policies and blueprints, how these work. One last thing that I want to mention is monitoring after the facts. We have a couple of things that come in Azure out of the box. One of the cooler things we have today is Azure Security Center, and we will look at Azure Security Center, especially when we're doing deployments from Azure DevOps, and from when we're doing deployments from any kind of system. We have a lot of things that can go wrong. And one of the things that can go wrong, some reason the browser is not cooperating with me. One of the things that can go wrong is when we push containers, for instance, that something goes wrong with the container image itself. So we do heuristic scanning on container images from a security center perspective. I'm quickly going to show you this. Bear with me for one more minute. There you go. And this is being done upon the push of your image after you build it inside any kind of organization, inside of any kind of CI/CD environment. And one of the things that you can see here, this container image scanning. So we power this by Qualys, and what this does is actually it scans your environment containers for weaknesses in either your hardening of your environment itself. So most of the containers run on some kind of Linux. So if they're badly managed, you can find them here. And as you can see, there's 40 severities that I can have. And this will then also give you highlights on how to resolve some of these things, like updating your image and doing stuff with those things. We also do scanning for other things, for like your Kubernetes deployment. We scan your registries for those things. So a lot of the cool things that are happening there. Next to that, we also have Sentinel, which can help you to secure your GitHub environment, for instance, and look at what things are going there. Unfortunately, I'm running out of time, so I don't have any demos on that, but this will give you a good insight on what's going on within your GitHub environment and who's fiddling around with it and where there is breaches on your data there. So, okay. More information is there. All the references are in here. I have a lot of references and some takeaways here. Read them after the thing, but the most important is always assume breach, try to do threat modeling, block lateral movement, and make sure that you have a secure and compliant pipeline when you're doing your coding part, okay? That brings me to the end. I went over time with 3 minutes. I apologize for the Q&A, of course, that is. So, let me see. There are some questions here that I see that they highlighted.
We have several questions.
I have several questions. So one of the first questions that there was is, which is better, secure hardware MFA or virtual MFA? It depends on the kind of system that you implemented. I mean, I have software implementation, which is really, really good. I have a Belgian partner that uses an EID as a real identity validation part, and which build a software around it, and it's based upon the phone, which is software and hardware at the same time. But even hardware like RSA tokens, depending on where the source is coming from, It could be either. Yeah? It's a very valid question. It's a very good question, by the way, because we don't give a lot of thought on what kind of solutions we have. But if you're using Google Authenticator or if you're using Microsoft Authenticator, at least use something. The most important part is that you use something to block access and to make it harder to people get into your environment and like really screw things up. You don't want that. That's the thing that you don't want to have. So whatever MFA you're using, there's no preference. There's no real preference. It depends on what you want to pay for it, what your industry requires, because sometimes there's a little bit of a difference inside of the requirements for MFA, and then you will be forced somehow into an hardware token, but at least use it. That's the most important part. So very good question. I also see some questions on the recordings. I leave that to the organizers because I have no idea there, but. Can you maybe, Maxime, answer that one on the recordings, whether they will be available, yes or no?
Yes, Mike. Maybe I will just read the questions that are to you from the audience. So one of them is the guys are using GitHub for the source code and GitHub Actions for the CI. And they also use Azure Container Registry for the images. So the question is, can they use AZSec DevOps scan to scan GitHub repo for ACR and ACR for vulnerabilities?
Yes, they can, because they can install it inside of a container, and then they can run AZSK and a PowerShell command line from there.
Okay, that's nice. Hope the guys will use it.
Yeah.
And next question is, does AZSK verify the compliance of the Azure infrastructure with architectural requirements?
Well, there's yes and no, because if you use additional tooling like Bicep, there's a new project, open source project, which will generate ARM templates. There you can actually do DSL building of your ARM template, and there you validate by the means of your architectural requirements. If you don't do that way, then no. But it will always validate against the best practices from a ARM template perspective and an Azure deployment perspective. So, so it's a hard question to answer, actually.
Yeah, no easy questions from the audience.
No. It's a good question, but I mean, I don't have a full answer on that one. That's what I mean. So.
Okay,
it's good.
Okay. Let's move to another one.
Yeah.
So firstly, thanks for the presentation. And at the beginning, you mentioned the importance of education in development as DLC. And the question is, what could you say about the CAMS model, culture, automation, lean measurement sharing, and how could it be implemented with Azure DevOps?
That's more a cultural thing, right? So you can implement it either way. To be honest, I don't have a valid answer on that one. It's something more that you need to take a look at with your organization. Lot of things, if you need to implement certain steps from in there, you can write them yourself. You don't have to work with the graphical user interface. You can create YAML files, you can do scripting. So there's a lot of things that you can just do yourself without having to work around a guided path that we prescribe.
Okay, great, thanks. And the last question that we had from the audience is, can you give some recommendations to those who currently don't use any security tools and want to implement it? So what is the best point to start from?
So if you're doing .NET and you're using Visual Studio, at least use the Security Intelligence plugin. Use that one, because that will already strictly help you on certain things. Look at, if you're using GitHub, just start the Dependa bot, and that will do the dependency scanning already. I didn't demonstrate that, but that comes for free on any kind of repo. So just already do that, and you will already have some scanning on packages that you use from third-party sources. Already do that. If you're not using, if you don't want to use any of these, just subscribe to Snyk, and most of it will work for you. And it's fairly easy. But the most important thing is that you need to know how to work with it too, from a cultural perspective. what are the risks? What that are we exposed to, and how should we react to those? So educate your users on the risks that there are. And then this is coming back to the previous question from the previous guy or person. Okay, so that's the most important part. But there's a lot of free tools that you can use, and look for what works best for you. Yeah? But for me, Snyk was an eye opener. Even for, it's a partner organization from us, and I love to endorse those guys, and they have lots of good content too.
Okay, great. Thank you for the answer. And now is the most hardest part. You need to pick the most interesting question.
Good. I'm in doubt between two. And I'm going to go for the, can we implement the AZSK in anything else? So the one that is said, what if we're doing GitHub Actions and AZSK and all these things? I'm going to go for that one. Yeah.
Okay.
And I hope you guys can find your way out of there. And if you want to know more about AZSK, there's a dedicated talk by a colleague of mine, Carl Otz. Look it up on YouTube, and we'll probably find a session somewhere on that thing. And he's a really good guy. He's a Microsoft MVP. He's a community guy. So really cool, really cool session. So if you want to learn more.
Awesome. Thanks for that advice. So thank you once again, Martin, Mike, for the presentation. It was really awesome and cool dive into security. Thank you guys for joining this session, and hope to see you on the next talks.
Yeah, thanks for having me.